When we speak of discovery in the human story, certain moments define us, moments when the veil of mystery is lifted and we glimpse truths that forever alter our understanding of reality. The James Webb Space Telescope's detection of water vapor in the atmosphere of an exoplanet only 26 light years away belongs to this category of world-changing milestones. To call it historic is not an exaggeration. It is the continuation of a legacy of human curiosity stretching from the first time ancient people looked at the night sky to the moment scientists launched JWST into orbit. This discovery is not just about data on a screen, it is about our identity as explorers, our destiny as seekers, and our deep yearning to know whether we are alone in this universe. To understand why this is historic, we must first remember what JWST is. The James Webb Space Telescope is not merely a tool, it is a dream made manifest. For decades, scientists envisioned a telescope powerful enough to peer into the earliest epochs of the universe, one that could pierce through dust clouds, observe the birth of stars, and analyze the atmospheres of planets orbiting distant suns. JWST was built to accomplish what seemed impossible, to bring us light from the edge of time and whisper secrets about worlds we could barely imagine. Its mirrors are gold-coated, designed with precision beyond comprehension, and its instruments are tuned to infrared light, allowing it to see the faintest signals traveling across billions of years. When JWST began sending back images, humanity stood stunned before galaxies dancing in cosmic webs, stars being born, and nebulae glowing like divine paintings. Yet among these marvels, one mission burned brighter than the rest: the search for signs of life. And now, just a short time into its mission, JWST has found water vapor on a planet orbiting a star 26 light years away. To put that distance into perspective, a light year is about 5 trillion kilometers. Multiply that by 26, and the mind begins to bend. And yet, in the ocean of the universe, this world is close, practically next door compared to other discoveries. That JWST can, across such vast gulfs of space, detect the chemical fingerprint of water in a planet's atmosphere is not only a technical miracle but a profound triumph of human intelligence. It is as if we have stretched out our senses far beyond the earth and gently touched the breath of another world. Why is this discovery so profound? Because water is more than just a substance. It is life's essential companion. On Earth, wherever we find water, we find life. From the icy peaks of the Himalayas to the boiling Hydra, thermal vents at the bottom of the ocean, life clings to water. Even the most extreme organisms, the tardigrades, the extremophiles, the microbes thriving in acid lakes, all require water to survive. It is the universal solvent, the medium in which biochemical reactions occur, the river in which life flows. To detect water elsewhere in the cosmos is to uncover a signpost pointing toward the possibility of life. It does not guarantee life, but it says loudly, here the conditions may be right. For centuries, philosophers and scientists speculated about worlds beyond Earth. The Greek philosopher Epicurus suggested in 300 BC that the stars were other suns and that countless worlds might exist around them. In the Renaissance, Giordano Bruno was burned at the stake partly because he dared to claim that infinite worlds must be out there, perhaps filled with beings like us. Later, with Galileo's telescope, we saw moons orbiting Jupiter and realized Earth was not the center of the universe. In the 20th century, astronomers began to speculate about exoplanets, but it was not until 1992 that the first was confirmed. Since then, thousands have been discovered, but for many years, these were only points of data, shadows crossing stars, numbers, and orbital charts. The real dream was to peer into their atmospheres to search for signs of chemistry that resembled our own. JWST has now taken us across that threshold. It has turned points of data into living skies. To detect water vapor is to say that this planet is not merely a rock orbiting a star. It has an atmosphere capable of holding and cycling molecules essential for life. This is not just discovery, this is transformation. Humanity has, for the first time, confirmed that in the space of our neighborhood, other skies hold the whisper of rain. Think of what this means psychologically and culturally. For generations, we gazed at the stars and wondered if we were alone. The silence of the cosmos seemed overwhelming, the vastness crushing, but now the silence has broken, not with a shout but with a whisper, a spectral signature of water. It tells us that the story of life may not be confined to one fragile blue dot. That our existence may not be a cosmic accident but part of a broader pattern, where worlds across the galaxy hold the potential for seas, rivers, clouds, and perhaps even beings gazing up at their skies as we do ours. The historic nature of this discovery also lies in the way it unites science and imagination. For decades, science fiction dreamed of worlds with oceans, alien landscapes rich with water, and civilizations arising under alien suns. Writers like Arthur C. Clarke, Isaac Asimov, and Carl Sagan gave voice to the possibility of water worlds, of life beyond Earth. JWST's discovery turns that fiction into something closer to fact. What was once confined to the pages of books is now recorded in data from an instrument floating in the vacuum of space. But history is not only made in the discovery itself, it is also made in what we do with it. The detection of water vapor raises new questions. What is the planet's temperature? Could liquid water exist on its surface, or is it locked in vapor high in the sky? Is the planet within its star's habitable zone where conditions are right for life? What other molecules linger in its air? Oxygen, methane, carbon dioxide? These are not idle curiosities, they are steps in the most important investigation humanity has ever undertaken. To find water is to open the door. To study what lies beyond that door will define the next century of exploration. We must also acknowledge the technological miracle that allows this. JWST's ability to detect water across light years is due to the technique of spectroscopy. When starlight passes through a planet's atmosphere, molecules absorb certain wavelengths of light. Water vapor has a distinct signature. It imprints itself on the spectrum. JWST can detect these faint signals, distinguish them from noise, and reveal the molecular fingerprint of another world's sky. Think of the delicacy of this task. It is like hearing a single drop of water fall in a roaring storm, or noticing the flicker of one candle on a horizon of 1,000 suns. That we can do this is testament to the brilliance of human engineers, scientists, and dreamers. This moment is historic also because it is shared. Humanity, divided by borders, politics, and struggles, still gathers under one sky. When JWST releases its findings, it is not the triumph of one nation, one culture, or one individual. It is the triumph of us all. We built this telescope together through collaboration, funding, and decades of perseverance. We sent it into space not as a weapon, but as a beacon. And now, as we absorb the news of water on a nearby exoplanet, we realize that discovery belongs to every child who looks up at the night sky with wonder. But there is a deeper historical resonance. Consider what future generations will say about us. Centuries from now, when our descendants travel between stars as easily as we now cross oceans, they will look back and point to this time. They will say, this was the moment when humanity first found water on another world. This was the turning point, the whisper that became a chorus, the signal that told us we were not confined to Earth. They will honor JWST as we now honor Columbus's ships or the Apollo missions to the moon. History will not remember the budgets debated, the technical setbacks, or the delays. It will remember the discovery, the moment the universe's silence cracked with the sound of water beyond Earth. There is also a spiritual element to this discovery. For many, the question of life in the universe is tied to deeper questions about purpose, existence, and meaning. If water and life exist elsewhere, it reshapes not only science but philosophy and theology. Are we unique creations or part of a vast cosmic family? Do the heavens hold only stars, or also brothers and sisters unknown to us? The detection of water does not answer these questions, but it presses them upon us with new urgency. Yet, as we celebrate this historic milestone, we must not forget the fragility of our own world. Water may exist 26 light years away, but here on Earth we struggle with drought, pollution, and climate change. The same substance that inspires our dreams beyond the stars must also inspire us to protect our rivers and oceans. If JWST has shown us the abundance of water in the universe, let that remind us to honor the water we have at home. The search for other worlds is not an escape, it is a mirror. reflecting back our duty to safeguard the only world we know that holds life. In conclusion, the discovery of water vapor by JWST is not a small step. It is a leap into a new chapter of history. It is a moment when human ingenuity touched the stars and brought back a truth older than we imagined, that the seeds of life are scattered widely, waiting to be found. We may not yet know if this exoplanet holds oceans, rivers, or living creatures. But we know this: the cosmos is not barren. It holds promise, potential, and perhaps even companionship. This discovery will echo through centuries as the day we learned that water, the giver of life, is not Earth's alone. And so, we stand at the edge of history, looking outward with awe, listening to the faint signal of a world whispering across the void. JWST has shown us water on a planet 26 light years away. One day, perhaps, our descendants will stand on its surface, watch clouds drift across alien skies, and remember this moment. They will say, here is where it began, the day we first knew that the universe was alive with possibility. That is why this discovery is historic. That is why it will never be forgotten. Water is more than a chemical compound. It is the very lifeblood of existence as we know it. Two hydrogen atoms bonded to a single oxygen atom create a molecule so simple and yet so profound that it has determined the fate of planets, civilizations, and entire ecosystems. When the James Webb Space Telescope revealed evidence of water vapor in the atmosphere of a planet just 26 light years away, the world celebrated not only a scientific achievement, but also the rediscovery of a truth that we often forget: water is the foundation of life. To expand upon this point is to enter a reflection not just on science, but on biology, philosophy, and the very essence of what it means to be alive in a universe that suddenly seems less empty. When we say the meaning of water, we mean more than its molecular formula. On Earth, water is the substance that ties together the entire chain of life. From the simplest microbe to the most complex mammal, every living being depends on water. It is the medium through which nutrients travel, the solvent in which biochemistry unfolds, the regulator of temperatures, and the protector against chaos. Our very cells are small oceans. Our blood is a river within us, carrying oxygen, minerals, and energy. Strip away water and life collapses into dust. On a planetary scale, water is equally vital. Earth itself is known as the blue planet, and not for its land but for its oceans. 71% of our surface is covered in liquid water. Without oceans, Earth would be a barren wasteland like Mars or Mercury. It is water that shapes climates, distributes heat, and stabilizes environments. The hydrological cycle, evaporation, condensation, rainfall, is the great circulatory system of our world, breathing life into every corner. Deserts remind us of its absence. Rivers remind us of its abundance. To live on Earth is to live in partnership with water. When JWST detected water on another world, it was not merely identifying a molecule in the void. It was hinting at the possibility of this same dance happening elsewhere. Imagine clouds forming in an alien sky, rain falling upon alien soil, rivers carving through alien landscapes. Imagine the cycles that sustain ecosystems, the potential for chemistry to become biology, and biology to become life. The meaning of water in this cosmic context is that it is a universal signature of possibility. Where water flows, life might grow. From a scientific perspective, the detection of water in exoplanet atmospheres is the holy grail of astrobiology. Life requires more than just water. Energy, nutrients, and stability are also essential. But water is the first and most fundamental step. Consider Mars. Evidence shows that Mars once had vast oceans, rivers, and lakes. Today, only traces remain, frozen in ice caps or hidden beneath the soil. Mars may never have developed complex life, but its watery past makes it the most studied planet in the search for alien microbes. If the presence of water shaped our interest in Mars, imagine what it means to find water on a planet orbiting a star just beyond our solar system. This exoplanet does not merely exist as a rock in the cold. It has the conditions that echo the story of our own Earth. Water is also deeply tied to human imagination and mythology. Nearly every culture on Earth reveres water as sacred. In ancient Mesopotamia, rivers like the Tigris and Euphrates were considered gifts from the gods. In Hinduism, the Ganges River is seen as holy, purifying the soul. In the Bible, water is the element of creation, baptism, and rebirth. In Greek mythology, the primordial god Oceanus embodied the endless stream encircling the world. From creation myths to rituals of purification, water symbolizes life, renewal, and possibility. When scientists tell us that JWST found water vapor light years away, it resonates not only with our scientific minds but also with the deep mythological and emotional layers of our species. It suggests that creation, renewal, and possibility are not confined to Earth but are written into the universe itself. Yet the meaning of water extends into the realm of survival. Our own history demonstrates how civilizations rise and fall with water. Ancient Egypt thrived along the Nile. The Indus Valley civilization flourished by rivers that sustained crops and communities. Conversely, droughts and water scarcity have destroyed societies, forcing migration, collapse, and war. Water is not simply life, it is power. Even today, nations fight over rivers and aquifers, while billions struggle for clean drinking water. That water is so vital to our existence gives this discovery immense weight. Finding it on an exoplanet, it is not just a scientific fact, it is a glimpse of survival written into the cosmos, a promise that the conditions necessary for thriving may be more common than we dared to hope. Biologically, the uniqueness of water lies in its extraordinary properties. It has an unusually high heat capacity, meaning it can absorb and release large amounts of heat without drastic changes in temperature. This makes it a stabilizer of climates, moderating environments where life can persist. Its solid form, ice, is less dense than its liquid form, which allows ice to float. Without this property, lakes and oceans would freeze solid from the bottom up, choking life beneath them. Water's polarity allows it to dissolve an incredible array of substances, turning it into the perfect solvent for complex chemistry. These properties are not trivial, they are the foundation of life's resilience. To find water elsewhere in the universe is to find the same physical properties that sustain us here. It means that the universe is not hostile by default but carries within it the same physics that nurtures life on Earth. The discovery of water vapor also changes how we view our place in the cosmos. If water exists only on Earth, then life here might be a rare, isolated miracle. But if water is scattered across planets, then the conditions for life might be common. Suddenly, the idea of alien life, once confined to speculation and fiction, becomes a scientific probability. We may not yet know whether life exists on that exoplanet 26 light years away, but the presence of water vapor strengthens the case that life could exist elsewhere. It transforms the question from "is life possible" to "how widespread is life?" That subtle shift carries enormous philosophical and cultural weight. There is also a poetic dimension to this discovery. Think of rain, one of the most universal human experiences. The sound of raindrops on rooftops, the sight of rivers swelling, the smell of earth after a storm. These experiences tie humanity together. To know that somewhere, perhaps not so far from us in cosmic terms, rain might fall on alien soil is to expand our imagination. It makes the universe feel alive, not barren. It makes the stars not just distant points of light, but neighbors holding worlds that share in our story. At the same time, the discovery challenges us. If water, the source of life, is found beyond Earth, then the universe is not empty but abundant. What then is our responsibility? Should we seek these worlds out, explore them, and perhaps one day colonize them? Or should we revere them, recognizing them as sacred places that mirror the sanctity of life on our own planet? The meaning of water is not only about possibility, but also about responsibility. We cannot celebrate water on exoplanets while we pollute our oceans and squander our rivers. The discovery should awaken us to our duty as stewards of Earth, even as it invites us to dream of other shores. Consider how this will shape the future. Today, JWST has detected water vapor. Tomorrow, more advanced instruments will measure its abundance, detect other molecules, and perhaps even reveal biosignatures, chemical hints of life itself. Future generations will look back on this as the moment the door opened. For them, water will not simply mean life on Earth. It will mean life throughout the galaxy. Children will grow up knowing that oceans may lap against alien beaches, that clouds may drift across alien skies, that life might emerge wherever water gathers. The meaning of water will expand from the familiar to the infinite. Ultimately, water is the language of connection. It connects our cells to the universe, our myths to our science, our survival to our future. To find it beyond Earth is to realize that the cosmos speaks in the same language we do. It whispers through rain and rivers here and through vapor and clouds there. JWST has taught us that this language is not Earth's alone. It belongs to the stars, to the planets, to the universe itself. So when we say the James Webb Space Telescope found water on a planet only 26 light years away, we are saying more than a scientific statement. We are declaring that the building block of life is not unique to Earth. We are acknowledging that the universe holds the same potential, the same sacredness, the same miracle that we find in every drop of rain. The meaning of water is not just survival, it is hope. It is the bridge between imagination and reality, between loneliness and connection, between Earth and the infinite. That is why this discovery resonates so deeply. It is not just water vapor detected in alien skies. It is life's signature echoing across the void, reminding us that we are not alone in our search for meaning. It tells us that the universe is not silent. It flows, it moves, it lives, and somewhere out there, on a planet circling a distant star, water falls, and with it falls the promise that life's great story has only just begun. For as long as human beings have gazed into the night sky, a single question has whispered to us from the stars: are we alone? This question is not just scientific, it is existential, emotional, and spiritual. It lies at the heart of who we are as a species. Every culture, every civilization, every generation has, in some form, wrestled with this mystery. And now, in our time, the James Webb Space Telescope, JWST, has brought us closer than ever to confronting it directly. Its detection of water vapor in the atmosphere of an exoplanet, it only 26 light years away, has reignited one of the most profound quests in human history, the search for life beyond Earth. When we speak of this search, we are not merely talking about scanning the skies for signals or cataloging distant planets. We are speaking of a journey that defines our species' identity. We are explorers, seekers, and storytellers. To search for life elsewhere is to search for ourselves. It is to ask, is life a unique miracle confined to Earth, or is it a universal phenomenon written into the laws of physics and chemistry? Are we an isolated spark in an endless darkness, or are we part of a galaxy alive with countless other flames? The discovery of water vapor is a signal that we are not chasing shadows. We are finding tangible evidence that the conditions for life exist beyond our world. Water is not just a substance, it is life's stage, and so, when JWST shows us water in alien skies, it tells us that the great search is no longer just a dream, it is a scientific reality. To understand the importance of this, let us look back at the history of the search. The idea of life beyond Earth is ancient. In ancient Greece, philosophers like Epicurus speculated that the universe was infinite and filled with countless worlds. In the Middle Ages, religious thinkers debated whether God might have created life elsewhere. In the Renaissance, as telescopes revealed moons orbiting Jupiter and mountains on the moon, humanity realized that Earth was not the center of all things. By the 20th century, astronomers had begun searching for planets around other stars, and scientists like Carl Sagan gave voice to the possibility of civilizations scattered across the galaxy. For decades, the search for extraterrestrial life took many forms. The search for extraterrestrial intelligence. SETI scanned the skies for radio signals, hoping to hear a message from other beings. Probes were sent to Mars, Venus, and the outer planets, looking for signs of life in our own solar system. Space agencies studied meteorites for fossilized microbes, and yet, despite these efforts, the silence of the cosmos persisted. We did not find signals, we did not find microbes, we did not find evidence that we were not alone. This silence weighed heavily on science and culture, giving rise to what became known as the Fermi paradox. If life is possible, if the galaxy is so vast, then where is everyone? Why do we not see evidence of other civilizations? It is here that JWST enters the story. Unlike earlier tools, JWST is capable of looking directly at the atmospheres of exoplanets, analyzing their chemical composition, and detecting molecules essential for life. This is a monumental leap forward. It means that we no longer have to guess blindly, we no longer have to speculate endlessly. We can now peer into alien skies and begin to answer the question with data. The detection of water vapor in an exoplanet, its atmosphere, is not just a minor achievement. It is proof that the search for life is moving from philosophy and speculation into measurable, testable science. But why is this so powerful? Because the presence of water increases the likelihood that life could exist. On Earth, life began in the oceans, from the first primitive cells to the explosion of biodiversity that fills our planet today. Water has always been the cradle of life. If water exists elsewhere, then the possibility arises that life followed a similar path there. The discovery does not guarantee life, of course, but it changes the probabilities. It shifts the search from maybe to possibly, from distant dream to scientific target. The search for life beyond Earth is not only about microbes or primitive organisms, it is also about the possibility of intelligent beings. For generations, humans have wondered whether there are civilizations out there, beings capable of thought, culture, technology, and exploration. If we are the only intelligent species, then the universe is lonely, and the responsibility upon us is enormous. But if intelligence has arisen elsewhere, then we are part of a greater cosmic story. The discovery of water vapor does not prove intelligence, but it expands the playing field. It tells us that the stage upon which intelligence could emerge is larger than we ever imagined. Culturally, the search for life resonates deeply. Consider how many books, films, and stories are devoted to aliens, to contact, to the mysteries of the cosmos. From ancient myths of beings from the sky to modern science fiction like Star Trek or Interstellar, we have always imagined companions among the stars. These stories are not just entertainment, they are reflections of our longing. They reveal our fear of being alone, our hope of finding kinship, and our curiosity about what lies beyond the familiar. When JWST finds water, it is as if those stories take one step closer to reality. It bridges imagination and evidence, myth and measurement, yet the search for life also forces us to reflect inward. Why do we seek it so desperately? Part of the answer lies in validation. If life exists elsewhere, then life is not a fluke. It is not an accident confined to Earth. It means that the universe tends toward life, that we belong to a greater pattern. Such a discovery would profoundly shift our perspective. Just as Copernicus displaced Earth from the center of the universe, just as Darwin revealed that humans are part of the tree of evolution, the discovery of extraterrestrial life would once again humble and redefine us. It would expand our identity from Earthlings to citizens of the cosmos. There are also practical reasons for the search. If life exists elsewhere, studying it would revolutionize biology, medicine, and technology. Imagine what we could learn from alien DNA, from alien ecosystems, from alien adaptations. Life beyond Earth would not only change our philosophy, it would change our science, our economy, and our survival. It would also provide hope. In a universe filled with life, extinction is not the end. Our story would be one thread in a vast tapestry, rather than the only thread in an empty void. Yet the search is not without challenges. Water vapor is only the beginning. For life to exist, many other conditions must align: the right temperatures, the right chemistry, the right stability over billions of years. Some planets may have water but no life. Others may have had life but lost it, and even if life does exist, it may not be recognizable to us. It may not use the same chemistry, the same forms, the same methods. The search requires patience, humility, and perseverance. The emotional impact of the search cannot be overstated. Imagine the moment humanity first confirms life elsewhere. Whether it is a microbe beneath Martian soil, a biosignature in the atmosphere of an exoplanet, or even a signal from a distant intelligence, that moment will redefine human history. Wars, borders, divisions, all will pale before the revelation that we are not alone. Humanity will gain not only knowledge but also perspective. We will see ourselves differently, as one species among many, as part of a universe alive with voices. JWST's discovery is a step toward that moment. It does not answer the question yet, but it tells us we are on the right path. It tells us that the conditions for life are not confined to Earth. It tells us that the universe may be filled with planets waiting to be explored, waiting to reveal their secrets. It assures us that our search is not in vain. The search for life beyond Earth is ultimately the search for meaning. If we are alone, then the responsibility to preserve and cherish life is immense. We are the guardians of the only spark in the dark. If we are not alone, then the universe is a grand conversation, and we are invited to participate. Either way, the search elevates us. It expands our minds, our hopes, and our vision. And so, when we celebrate JWST's detection of water vapor, we are not just celebrating a scientific fact. We are celebrating the continuation of humanity's oldest dream. We are celebrating the hope that one day, perhaps soon, we will answer the question that has haunted and inspired us for millennia. Are we alone? With each discovery, the answer grows clearer, perhaps not. In the end, the search for life beyond Earth is not about distant plan, it's alone, it is about us. It is about who we are, what we value, and what we hope to become. To seek life is to affirm life. To seek companionship among the stars is to acknowledge our longing for connection. And to find water on a world 26 light years away is to glimpse the possibility that the universe, vast and ancient, is alive with more than just silence. It is alive with potential, with stories, with life. The search continues, and with JWST, it has taken a historic leap forward. When people first hear that water vapor has been detected on an exoplanet, their immediate reaction is often awe, followed by a sense of distance. After all, the word light, year, conjures unimaginable expanses, gaps so vast that they seem insurmountable. Yet when we say that the James Webb Space Telescope has found water on a planet only 26 light years away, we are talking about nearness in a cosmic sense, a closeness that redefines what it means to be neighbors in the universe. To grasp the true magnitude of this, we must understand both the immensity of space and the intimacy of this discovery. Let us begin by considering what 26 light years really means. One light year is about 5 trillion kilometers. 26 of those is an almost incomprehensible number, roughly 247 trillion kilometers. By human standards, this distance is impossible to traverse with current technology. Our fastest spacecraft would take tens of thousands of years to reach it. Yet when compared to the scale of the galaxy, this exoplanet is practically in our backyard. The Milky Way spans 100,000 light years across. There are over 200 billion stars within it, many with planets of their own. Against this canvas, 26 light years is a short stroll down the street. If the galaxy were the size of Earth, this exoplanet would be just a few steps away. This nearness changes everything. For centuries, humanity has looked at the stars with both longing and resignation. The dream of other worlds has always been tempered by the reality of their distance. To find potentially habitable conditions, water vapor, no less, so close to us suggests that such discoveries may not be rare at all. If we can find one so nearby, how many more must there be scattered just beyond the horizon? The universe, it seems, may be teeming with planets carrying the same essential ingredients of life, and some of them are close enough to touch the imagination. The nearness of this discovery also reshapes the timeline of exploration. When exoplanets were first discovered in the 1990s, they were seen as distant curiosities. We knew they existed, but they felt unreachable, almost like stars in their remoteness. Now, however, the story has shifted. A planet only 26 light years away is not unreachable forever. It is unreachable for now. That distinction matters. Human technology is advancing at an exponential rate. Telescopes grow sharper, propulsion systems grow faster, and our understanding of spaceflight deepens. What seems impossible today may become plausible tomorrow. Just as powered flight went from impossible dream to everyday reality in a matter of decades, so too could interstellar travel one day shift from fantasy to engineering. Consider how this changes the way we view our future. If water vapor had been found on a planet thousands of light years away, it would still be monumental, but it would remain a distant marvel. To find it so near, however, places it within the realm of our descendants' reach. Imagine humanity in 1,000 years, or even just a few centuries, armed with technologies we can barely conceive of now. Nuclear fusion propulsion, solar sails powered by lasers, or even wormhole engineering may shorten journeys to neighboring stars. When that time comes, a world only 26 light years away will not be a distant point. It will be a destination, and this discovery will be remembered as the moment we first knew that such a destination existed. The psychological impact of nearness cannot be overstated. Throughout history, exploration has always been fueled not only by curiosity but also by attainability. Sailors crossed oceans not because they dreamed of infinite horizons, but because they saw islands shimmering just beyond the mist. The same will be true of space. Knowing that a potentially water-rich planet exists within a cosmic stone's throw inspires more than wonder, it inspires intent. It tells us that our future is not confined to Earth. It suggests that humanity has places to go, goals to achieve, and neighbors to one day meet. Furthermore, the nearness of this discovery reframes the question of rarity. For decades, scientists have debated the probability of life beyond Earth. Some argued that we might be unique, a singular oasis in a barren desert, but if water vapor can be detected just 26 light years away, it implies abundance. If we stumble upon such conditions so soon, so close, what are the odds that the universe is barren? Surely they are low. The nearness of this discovery tilts the scales toward a cosmos filled with possibilities, rather than one echoing with emptiness. This sense of nearness also changes the way we dream. Humanity has always needed symbols of the possible. In the 1960s, the moon became such a symbol. It was close enough to touch, and so we went. Mars has taken on this role for our generation, distant but achievable within a lifetime. A planet 26 light years away is too far for us now, but it stands as a new horizon for the generations to come. It is a reminder that exploration does not end with Mars or even with the outer planets. It is a promise that beyond our solar system there are destinations waiting, tantalizingly near in the vast ocean of stars. There is also a poetic element to this nearness. Imagine standing on Earth, looking up at the night sky, and realizing that one of those faint points of light hosts a planet with water vapor in its skies. It is not a star billions of light years away, but a star close enough that our telescopes can read its atmospheric signature. To know that within that tiny glimmer lies a potential mirror of Earth fills the night sky with intimacy. The stars are not cold and distant, they are neighbors with stories to tell. Philosophically, the nearness of this discovery also challenges us. If life could exist so close, what does that say about our place in the universe? Are we one of many scattered across the galaxy, each unaware of the others, or are we meant to bridge the distance, to reach across the void and make contact? Nearness implies not only possibility, but also responsibility. It suggests that the search for life is not an abstract exercise, but an immediate task, a calling placed directly at our doorstep. This nearness also resonates in a sobering way. If life does exist only 26 light years away, then it has likely existed there for millions or even billions of years. Why then have we not seen evidence of it? Why no signals, no probes, no clear signs? This brings us again to the Fermi paradox, the haunting silence of the cosmos despite the apparent abundance of habitable worlds. The nearness of discovery deepens this paradox. If the conditions for life are close at hand, why do we not yet see life itself? Perhaps it is rare after all. Perhaps civilizations destroy themselves before they can reach others, or perhaps we simply have not learned how to listen properly. Whatever the answer, the nearness of this discovery forces us to confront the paradox more urgently than ever. From a scientific perspective, the fact that JWST can detect water vapor at this distance is itself astounding. 26 light years is far, yet our technology can discern the chemical composition of a planet's atmosphere across that gulf. Imagine what we will be able to do as instruments grow sharper. Today, we can detect water vapor. Tomorrow, we may detect oxygen, methane, carbon dioxide, or other biosignatures. Within decades, we may be able to map the climate of these worlds, to see their clouds, to study their surfaces indirectly. Nearness does not only mean physical proximity, it also means observational accessibility. This world is close enough for us to study in detail, to learn from, to make a part of our expanding knowledge. In cultural terms, the nearness of this discovery gives humanity a shared horizon. We live in a time of division, of fractured politics and global challenges. Yet discoveries like this remind us that above all our differences, we share one sky, we share one search. A planet 26 light years away does not belong to one nation or one people, it belongs to us all. It is a symbol of unity, of a shared future, of a common destiny among the stars. Ultimately, the nearness of this discovery transforms the way we think about the future of humanity. It is no longer about whether life might exist out there in the distant unknown. It is about realizing that the conditions for life exist right next door on a cosmic scale. It tells us that exploration is not endless speculation, but a concrete path with milestones already visible. It tells us that humanity is not wandering blindly into the dark, but is stepping forward toward neighbors we have only just begun to see. So when we say that JWST has found water vapor on a planet 26 light years away, we are not just reporting a scientific fact. We are announcing a revelation of proximity. We are saying that the cosmos is not a distant dream, but a neighborhood full of wonders, and we have just discovered one of the houses nearby. This discovery invites us to imagine, to prepare, and to believe that one day, perhaps sooner than we think, humanity will not only gaze at such worlds, but touch them, walk upon them, and call them part of our greater home. The nearness of this discovery is in many ways more important than the discovery itself. It is not just that we found water, it is that we found it here, so close, so tangible, so accessible in the vastness of space. It is as if the universe has leaned down and whispered in our ear, "Look closely, you are not alone, the possibilities are nearer than you think." When the James Webb Space Telescope detected water vapor on an exoplanet just 26 light years away, the world stood still in awe. For the scientific community, it was nothing less than a triumph, a vindication of decades of work, billions of dollars in investment, and centuries of human curiosity that drove us to build instruments capable of peering across cosmic oceans. This discovery is not just about water. It is about what water symbolizes: possibility, habitability, and the reminder that the universe may be more welcoming to life than we ever dared hope. Yet this triumph carries with it a shadow of responsibility. As we expand our knowledge of the cosmos, we must also confront the ethical, environmental, and existential questions that arise when humanity steps onto this new frontier. The triumph is, first and foremost, technological. The James Webb Space Telescope is an engineering masterpiece, one of the most complex machines ever built by humans. It orbits the Sun nearly 1 million miles from Earth, stationed at the L2 Lagrange point where gravitational forces create a delicate balance. Its segmented gold-coated mirror, over 6 meters across, captures faint starlight with exquisite sensitivity. With instruments tuned to the infrared spectrum, JWST can peer through cosmic dust and analyze the faintest flickers of light filtering through an exoplanet, its atmosphere as it passes in front of its star. From those faint imprints, scientists can read the signatures of molecules like water vapor. The fact that we can do this, decipher the chemical makeup of a world dozens of light years away, is one of humanity's most remarkable achievements. It is also a triumph of perseverance. This telescope was not easy to build. For decades it faced delays, redesigns, and skepticism. Its budget ballooned to nearly $10 billion. Critics wondered if it would ever launch. Yet against all odds, in December 2021, it soared into the sky and unfolded perfectly in space, a ballet of precision where a single failure could have doomed the mission. That it now sends us discoveries like water on a nearby exoplanet, it is proof of the resilience of human ambition. Science is not only about equations and data, it is about the will to reach beyond limits, the courage to dream, and the dedication to overcome setbacks. Beyond the triumph of engineering lies the triumph of knowledge. Water has always been the holy grail of space exploration. From the dry deserts of Mars to the icy moons of Jupiter and Saturn, scientists have chased traces of water because they know it is the bedrock of life as we understand it. To find water on a planet orbiting another star transforms our understanding of the universe. It tells us that Earth is not unique in its possession of life's key ingredient. It tells us that the recipe for habitability may not be rare. It whispers that the cosmos could be abundant with planets where rivers once flowed, where clouds gather, where rain might fall. Yet as glorious as this is, it also sharpens our responsibility. Knowledge without wisdom can be dangerous. We are at a turning point in history. For the first time, we are gaining the tools to detect, study, and perhaps someday visit other worlds. How we use that ability will shape not only our destiny, but also the destiny of any life that may exist out there. Responsibility begins with humility. We must resist the temptation to see other worlds as resources to be consumed or as blank canvases for human expansion. Instead, we must view them as places with their own intrinsic value, their own rights to exist unspoiled. If we find life, even microbial life, we must consider it sacred, for in that life lies the story of the universe told in a language not our own. Responsibility also means turning our gaze inward. Discovering water vapor on another world reminds us of the fragility of our own. Earth is drenched in water, wrapped in a breathable atmosphere, bursting with ecosystems, yet we treat it recklessly. Climate change, pollution, deforestation, and overconsumption threaten the very foundation of life here. What good will it do to find oceans on distant planets if we cannot preserve the oceans we have at home? The triumph of discovery cannot blind us to the urgency of stewardship. The stars inspire us, but Earth sustains us. Scientific triumph must walk hand in hand with environmental responsibility. This responsibility extends beyond the environment into the realm of ethics. As we expand our reach into the cosmos, we must ask hard questions. Should we attempt to colonize worlds where life already exists? Should we send probes that may contaminate pristine environments? Who decides how discoveries are used? Scientists, governments, corporations? Space has always been a domain of wonder, but it is also becoming a domain of competition. Nations vie for supremacy, companies seek profits, and militarization looms. If water on a nearby exoplanet becomes the justification for resource extraction or territorial claims, we risk repeating the mistakes of history: colonialism, exploitation, conflict on a cosmic scale. The triumph of science must not become the tragedy of conquest. Another layer of responsibility lies in communication. The discovery of water vapor is thrilling, but it is not proof of life. Scientists must walk a careful line between inspiration and exaggeration. To oversell findings risks disillusionment, while to undersell them risks losing public engagement. The triumph of science depends not only on data, but also on trust. When scientists share their discoveries with the world, they carry the responsibility of honesty, clarity, and humility. They must remind us that this is one step in a long journey, not the final answer to the question of life beyond Earth. At the same time, responsibility means ensuring that the benefits of discovery are shared. The James Webb Space Telescope was funded by taxpayers from around the world. Its knowledge belongs to humanity, not to a privileged few. Open data policies, international collaboration, and public access to images and findings are essential. The cosmos is not the property of one nation or one corporation. It is the shared inheritance of all who look up at the night sky. The triumph of science must therefore be coupled with the responsibility of inclusion, ensuring that the awe of discovery reaches every corner of Earth. This balance between triumph and responsibility is not new in human history. When we first split the atom, it was a triumph of physics, but it came with the responsibility of nuclear power and weapons. When we cracked the code of DNA, it was a triumph of biology, but it came with the responsibility of genetic engineering and ethics. Now, as we detect water on worlds beyond our own, we face a similar moment. It is a triumph of astronomy, but it comes with the responsibility of deciding how humanity will meet the cosmos, as conquerors or as caretakers, as exploiters or as stewards. It is worth remembering that science, at its best, is not separate from morality. The ancient philosophers who gazed at the stars did not see a division between knowledge and virtue. They believed that to understand the universe was to live in harmony with it. Modern science has given us unparalleled power, but power without wisdom is perilous. The discovery of water vapor on a nearby planet is a gift, a reminder of what we are capable of and a test of what we will become. Will we use this gift to fuel our imagination, to inspire future generations, to deepen our respect for life? Or will we use it to justify exploitation and escape? Responsibility also demands patience. As eager as we are to imagine other worlds, we must remember that exploration is a long, slow process. Telescopes gather data, theories are refined, missions are planned decades in advance. It may take centuries before we can reach that planet 26 light years away. But in the meantime, responsibility means nurturing the culture of science, supporting education, funding research, and cultivating curiosity in young minds. Today's discovery is tomorrow's foundation. If we neglect that responsibility, the triumph of this generation may fade into the silence of forgotten potential. There is also a spiritual dimension to this balance. For many, the discovery of water on another world is not just scientific, it is existential. It challenges our sense of uniqueness, our place in creation, our understanding of what it means to be human. Responsibility here means openness, the willingness to embrace wonder, to expand our philosophies, to see ourselves as part of a vast, interconnected cosmos. Triumph gives us facts, responsibility gives us meaning. Only together can they give us wisdom. Let us also not forget that the triumph of discovery belongs not only to scientists but to humanity as a whole. Each time we push the boundaries of knowledge, we affirm the best of what it means to be human. But responsibility demands that we carry everyone with us, that we ensure the wonders of discovery are not confined to ivory towers or wealthy nations. A child in a remote village staring up at the stars has as much right to this wonder as a scientist in a lab. To democratize the cosmos, to share the triumph with all, is one of our greatest responsibilities. In the end, the detection of water vapor on a nearby exoplanet is both a crown and a challenge. It is the crown of centuries of human striving, a shining symbol of what we can achieve when we dare to dream, but it is also a challenge to our conscience, our ethics, and our priorities. Will we prove worthy of this triumph? Will we pair it with the responsibility it demands, or will we squander it, chasing glory while ignoring the lessons of humility? The answer lies in how we act today. Every choice we make to protect Earth, to pursue science ethically, to share knowledge openly, to respect the possibility of life elsewhere, shapes the path ahead. The discovery of water vapor is not an ending but a beginning. It is an invitation to walk wisely into the future, to marry triumph with responsibility, to honor the gift we have been given. So let us celebrate this triumph with joy, but let us also accept its weight with courage. For in this moment the universe has handed us both a crown and a burden. We have proven that we can reach the stars. Now we must prove that we are worthy to walk among them. The discovery of water vapor on an exoplanet at just 26 light years away is more than a scientific achievement. It is a turning point in human history. For centuries, humanity has gazed at the stars and wondered what lay beyond. We built myths, mapped constellations, and searched the heavens for meaning. Now, with the James Webb Space Telescope, we are no longer dreamers looking at distant lights. We are explorers standing at the threshold of something new. This discovery is not the end of a journey, it is the beginning of a new chapter in human exploration, one that will redefine our place in the universe. To appreciate the magnitude of this moment, we must first look back at how far we have come. Human exploration began humbly with small steps across rivers, mountains, and deserts. Our ancestors crossed oceans in fragile boats, not knowing if land awaited them. Each step into the unknown was driven by curiosity, necessity, and courage. The age of exploration transformed our understanding of Earth. Space exploration, beginning in the 20th century, extended that spirit into the cosmos. When humans first walked on the moon, we proved that our species was not bound to one world. With robotic probes, we touched Mars, Jupiter, Saturn, and even Pluto. The Voyager spacecraft carry our presence into interstellar space, and now, with telescopes capable of analyzing the atmospheres of other worlds, we have taken the first step toward exploring planets orbiting other stars. The detection of water vapor on a planet only 26 light years away is a clear signal the frontier of exploration has expanded again. This discovery is a page turner, a shift in the story of humanity. For the first time, we are not only looking at distant stars but beginning to study the planets that circle them in detail, and the fact that water, a prerequisite for life, has been found so near us suggests that this new chapter will be rich with possibility. What does it mean to enter this chapter? First, it means shifting our imagination from local to interstellar horizons. For decades, the dream of exploration has centered on Mars. Colonies on the red planet have been the symbol of humanity's next step. But Mars is not the end of the story. It is a stepping stone, a training ground, the first rung on a cosmic ladder. With the discovery of potentially habitable conditions on exoplanets nearby, the ladder now stretches far beyond our solar system. A new chapter means lifting our gaze from Mars to the stars. Second, this chapter means rewriting our understanding of life's possibilities. Until recently, the search for life was focused on Mars, Europa, and Enceladus, worlds within our solar system that might harbor oceans beneath ice. Now, we know that planets around other stars also hold water. This changes the framework entirely. Life may not be confined to hidden oceans in our backyard. It may exist openly on planets orbiting suns just a short distance away in cosmic terms. A new chapter means that the universe is no longer a silent backdrop. It is a stage that may be filled with voices we have yet to hear. Third, this chapter is about preparing for contact, not necessarily with intelligent beings, but with the reality of other living systems. Even if we find only microbes on another planet, it will be one of the most profound discoveries in history. It will prove that life is not unique to Earth. It will show that the universe, given the right conditions, almost naturally gives rise to living systems. And if life is abundant, then so too may be intelligence, civilizations, and cultures beyond our own. A new chapter means humanity must prepare its philosophy, its science, and its spirit for the possibility that we are not alone. But this chapter is not just about discovery, it is about destiny. For the first time, we can see a roadmap unfolding. Exploration is no longer limited to imagination, it is guided by data. We now know where to look. The star systems closest to Earth may hold planets with water, atmospheres, and conditions ripe for study. In the coming decades, new telescopes will peer even deeper, searching for oxygen, methane, and other biosignatures. Missions may be designed to travel toward nearby stars, propelled by new technologies such as light sails driven by powerful lasers. Though such journeys may take centuries, the seeds are being planted now. A new chapter means that our future is not confined to Earth but written into the stars. This discovery also challenges our cultural imagination. For generations, science fiction has dreamed of other worlds, planets with oceans, skies, and alien civilizations. These stories were once pure speculation. Now they are grounded in evidence. The exoplanet with water vapor is not a fantasy. It is real, orbiting a real star, waiting for us to learn more. Science fiction is merging with science fact, and the boundaries of imagination are expanding. A new chapter means that the stories we tell will be different, richer, deeper, closer to reality. Children growing up today will not ask, could there be other habitable planets? They will ask, which one will we go to first? Yet, as with every new chapter, there are responsibilities. Exploration is never neutral. The same discovery that inspires wonder also demands caution. A new chapter means asking hard questions. Should we send probes to these planets, knowing that contamination is possible? Should we plan for colonization if they are habitable, or should we leave them untouched? Who will decide the ethics of interstellar exploration? The scientists, the nations, or humanity as a whole? Just as the age of exploration on Earth brought both discovery and exploitation, so too could this new chapter bring both glory and danger. This moment also forces us to confront our identity. Who are we as a species stepping into the cosmos? Are we explorers, caretakers, conquerors, or wanderers? A new chapter means we must define ourselves anew. For the first time, we have the opportunity to decide consciously how we will meet the universe. Will we repeat the mistakes of history, or will we enter this chapter with humility and respect for life? However it may appear, at the heart of this chapter lies hope. For many, the thought of Earth's fragility is a source of fear. Climate change, resource depletion, and conflict threaten our future. But discoveries like this remind us that humanity is not trapped. The universe is wide, filled with potential. Even if Earth faces trials, the stars offer possibilities. This does not mean abandoning Earth. On the contrary, it means valuing it even more. But it also means believing that humanity has a future larger than one planet. A new chapter means embracing hope that our story is only beginning. And let us not overlook the symbolic power of this discovery. Water is life's mirror. To find it elsewhere is to see ourselves reflected in the cosmos. It tells us that we belong to a larger narrative, one written in the language of hydrogen, oxygen, and carbon, the universal chemistry of existence. A new chapter means recognizing that we are not isolated beings but participants in a cosmic story that began long before us and will continue long after. Practically, this chapter will shape science, technology, and education. Already, research in astronomy and astrophysics is expanding. Universities are training the next generation of scientists to analyze exoplanetary atmospheres. Engineers are developing propulsion systems for interstellar exploration. Governments and private companies are investing in space missions that seemed unthinkable just decades ago. A new chapter means humanity is building the tools not just to dream of other worlds, but to reach for them. There is also a unifying aspect to this moment. In a world divided by politics, borders, and ideologies, the cosmos is shared. The discovery of water on a planet 26 light years away does not belong to one nation, it belongs to humanity. It is a reminder that beneath our divisions we are one species, sharing one planet, looking up at the same stars. A new chapter means that the future we write will not be the story of separate nations, but of humanity as a whole reaching into the universe. Of course, challenges remain. Interstellar travel is still beyond our reach. The distances are vast, the technology daunting, the costs enormous, but exploration has never been about ease. When our ancestors crossed oceans, they did not know if they would return. When we built rockets to the moon, we risked lives and resources in pursuit of a dream. Each chapter of exploration has been marked by difficulty, yet each has advanced us further than we thought possible. This chapter will be no different. It will test our patience, our ingenuity, and our will, but it will also reward us with wonders beyond imagination. The beauty of this moment is that it belongs to all of us. Whether scientist, student, poet, or dreamer, every person on Earth has a stake in this story. When we look up at the star that hosts this water-bearing planet, we are reminded that the universe is not silent or indifferent. It is speaking to us through light, through chemistry, through discovery. A new chapter means listening, responding, and embracing our role as explorers of the infinite. So what is this chapter, truly? It is not about rockets or telescopes alone, it is about transformation. Humanity is shifting from a species confined to one planet to a species aware of its cosmic neighborhood. We are awakening to the realization that life's possibilities are broader, richer, and nearer than we ever imagined. This chapter is about growing into that awareness, taking responsibility for our actions, and daring to dream of futures that stretch far beyond our current horizons. Let us then celebrate this discovery for what it is, not just a detection of water, but the opening of a door. The universe has placed a key in our hands, and behind that door lies the next chapter of our story. The ink is fresh, the pages are blank, and we are the authors. Whether we write a tale of wisdom or folly, unity or division, hope or despair, depends on us. But one thing is certain, the story will not end here. A new chapter in human exploration has begun. The James Webb Space Telescope has shown us that water exists on a nearby world. The universe has invited us forward. Now it is up to us to answer, to step across the threshold and to carry our story into the stars.